All right, occasionally you get a system of inequalities. So you're going to have two equations. They're going to have a y and an x, but they might be set up with inequalities instead of equations. So when that happens, you're going to graph them on one grid, just like we did with regular graphing. You got to be really careful with inequalities about that solid versus a dashed line, or shading above versus shading below the line. So to kind of jog your memory on that, in this example, this is good because it's already in that mx plus b that I like. So I'm going to start, it begins at -2. My slope here would be 1 over 1. So I'm going to go up 1 over 1 several times. But the added part when you're graphing inequalities is you've really got to think about, okay, it's not equal to. So that means this is a nice dotted line. And some of you guys, when we were doing this back earlier in the year, you would just connect like every other dot. I don't hate that idea. I kind of like that idea. And then you also have to keep in mind, am I shading above or shading below? So if I want y to be greater than my line, greater than my mx plus b means I'm going to start on my y and I'm going to shade everything above that. Okay, so I'm just going to use my highlighter and shade everything above that line. And I'm kind of color coding here just so it's super clear where I'm getting everything from. But there is my graph, okay? It actually goes right up to the line without including the line, right? Because it's not equal to. All right, my second situation, y equals -3x, is also already in mx plus b. So I'm going to begin at 0. And -3 over 1 means I'm going to go down 1, 2, 3 over 1. Notice we don't have a clean intersection on this. That's actually not a big problem with inequalities. And up 1, 2, 3 over 1. Now this one, because it's equal to, I can go ahead and draw a nice solid connected line. I don't have to worry about that dashed line. And then it says, okay, y is less than that line. So if I want less than that line, I usually start with the y-intercept, and I want everything that is less than that. So I'm going to shade everything underneath. When we did this in class, I cautioned you against thinking left and right. Instead, think above and below. Okay, so you start to see a picture of what we actually have happening here. I've got the pink shading for one problem, the purple shading for the other problem, okay? So that's where we start. We graph them. Now it says the solution is all the coordinates in the area that are shaded by both. So you don't just end up with one solution on these. It's actually any coordinate that's in that space shaded by both. So if I look, I want the pink section and the purple section, which puts me all in this section right here is really what I'm talking about. So I can pick any coordinate there that's falling in that section. So for example, I could say, well, that dot right there is in the section. So that would be negative. I know it's really hard to see with the highlighting, but it would be at -2 and 0. So possible solutions. And these, you're not going to have a specific, like there's a bunch of different answers that could work. -2, 0. Is in that section. Let's see, -5, 2. I don't think that's actually -5, but -5 and up 2 would be in that section. You start looking at, okay, well, what about this actual dot? Well, it's purple because it's on a solid line, and it's in the pink shaded section, so that would actually work back there at -1, 3. Okay, what about this one, this dot here? Well, it's definitely in the middle of that purple section. That's not a problem. But my pink line here is actually a dotted line, which means I cannot include that. So be really careful. That actually is not. So let's see, that would be at -1, -3. I'm going to write it, and then I'm going to cross it out so that I know that that dot right there is actually not a solution because it's on the dotted line. Okay, so it has to be on a solid line if it's on a line. It doesn't work if it's on a dotted line, okay? So you just graph them and then look for any point. And seriously, there's like an infinite number of values that you could pick over here. I just picked a few as kind of examples of ones that would count as solutions, okay? All right, in our second example, the first part of it, pretty simple, okay? I've got my mx plus b, so this is going to begin at 1, and then I hope we're getting pretty comfortable at filling in my slope of 1 over 1. Let's see, this would be actually a solid line because it says equal to, so I'm going to go ahead and draw a nice solid line through those dots. And it says I want less than that line. So I'm going to use my highlighter to highlight everything underneath that line. It doesn't have to be a perfect highlighting job, just so I have an idea. Now, the second equation is a little trickier because I don't have mx plus b yet. I don't have y isolated. So I'm going to divide by -4. And I'm going to divide each of these by -4. This has kind of seemed like the easiest way to do that for those of you who are struggling. This cancels out, and remember with inequalities, when you divide by a negative, something happens to that symbol. It flips around. So now I'm actually talking about greater than, I can't really divide 3 over -4, so I'm just going to leave it as -3/4 x. -12 divided by -4 would actually go to +3. So I'm going to start at 1, 2, 3. I'm going to go down 3 over 4. 1, 2, 3, 4. Down 3 over 1, 2, 3, 4. Up 3, back 1, 2, 3, 4, just to really finish out that pattern. This one cannot equal. So I'm going to draw a dotted line here as best as I can, kind of at this weird angle. It's a nice dashed line happening. And I want greater than now because it flipped around. So I'm going to take this spot and I'm going to go above that line. I'm kind of ignoring the pink. I'm just blocking out the pink for a minute, and I'm going to shade all this purple stuff that's above the line. Okay? So now when I go to do possible solutions, the actual solution is in this double shaded portion, all this stuff that's shaded by both. So possible solutions, again, there are an unlimited number. I'm just going to pick a few. So let's see, this dot looks good. If I actually count that out, it would be 1, 2, 3, 4, 5, and up 2 would be an answer. Let's go out to 7, 0, or 6, 0 would be an answer, right? It's clearly in that double shaded portion. If you want to get tricky, you can go to a point on the line. Just make sure you don't use a point on the dotted line. If there's a solid line, you can use a point on a solid line. So if I use that one, let's see, that would be over 1, 2, 3, 1, 2, 3, 4. So +3, +4. Okay? So you're just going to give a few possible coordinates that fall in that double shaded portion. So remember that graphing needs mx plus b. If it doesn't have mx plus b right off the bat, you're going to have to isolate y first to get that. Okay? So it's just really graphing and then looking at where it's shaded more than once.